In this presentation I'd like to give an update of the current status of the LibreOffice GTK4 port. And the first thing I'd like to do is So here we have our demo of the GTK4 version. We can clearly see something on screen and it looks like LibreOffice should. If we look at the menus, we see we have functioning menus. Here we can see that the menu is too tall to fit in the available space. We now have scrollable menus with a scroll bar in the side. The classic first dialog to look at is the word count dialog. Here we can see that the buttons have now migrated to the top of the window instead of the classic at the bottom. All of the help buttons are now replaced by this little indicator instead. The other classic dialog is insert manual break. Here again the same top level buttons, and here's an example of a combo box with a drop down menu working, and if we enable that we have a functioning spin button there like that. Look at more ones. If you insert table, slightly more complicated dialog. Here we have our tree view down here functioning perfectly fine, and preview is updated as we select each entry. Check buttons. Then if we look at format character, and we have the usual notebook, multiple tabs, color selectors, all functioning under GTK4. Over here, or drop-down menus, custom widgets can be interacted with, and drop-downs also working. The famous double-decker notebooks also functioning as well. Can't fit them into the ordinary space available. The two-level mode is also working fine. If we look over in Impress and select that and check down here, we can see that we have functioning OpenGL slide transitions in preview mode at least. We don't have them working yet in full screen, but there is enough functioning to show that it will work in the end. Typing works, of course. Context menus work. Context menus now slide like this. So what has changed in GTK4 from GTK3? The first obvious thing is how events are managed has changed. In GTK3, to get mouse and keyboard events and so on, you can connect directly to the GTK widget and connect to the signals such as the key press event, key release event, and so on. Now to do that, you have to create an event controller for the type of event you're looking for. In this case, key events. You add that controller to the widget and then connect to the key press, key release events at the controller level. This has knock-on effects to other parts of the API as well, so things like input methods and whatnot are all correspondingly changed to be to work with controllers instead. This makes a lot of things actually more simple from our perspective. That GTK event itself is now opaque and you can't pull out its individual members. Either some accessors have been added, or in many of the cases the required data that we need appears as arguments to the controller callbacks. All of this is relatively straightforward from a LibreOffice perspective. Cut and paste. Well, the first simple thing is that GTK clipboard has basically been renamed to GTK clipboard. The way we want to operate with the clipboard is that we just want to get the formats that are available in the clipboard, their MIME types, and then we just want to get the raw data of that, and afterwards we do the conversion ourselves into our own internal formats, or vice versa from our own external formats. We put them into the clipboard and we just want to have that view of things. The first change in GTK4 is that there's now an API available to let us know that we are pasting from ourselves. GTK clipboard is local. That's convenient and can replace a horrible hack that we're using in the GTK3 version. So that's a positive. In the GTK3 version, it used to be that formats were identified by GTK atoms, and we got the MIME type of that format by calling GTK atom name to get that, and then we would call GTK clipboard wait for contents to get the data synchronously and convert the data returned from that to the various formats that we use internally. Fairly straightforward from our perspective. It's more complicated now with GTK4. We can use GTK clipboard get formats, and we have the ability to call GTK content formats get MIME types and that to get the MIME types that we want, so that's more straightforward than the previous mechanism. But there's only an asynchronous mechanism to get the data now. You have to call GTK clipboard read async, and then a whole set of callbacks are triggered by that, and you're given a GTK input stream to read the data from, and you read a chunk of data, and then you return back to request it to read the next chunk, and eventually it'll arrive back with the final chunk, and at which point you have all the data that you need from the clipboard. So it's a more roundabout mechanism from our perspective. It basically was already doing something very similar to that, but it was hidden behind the GTK clipboard wait for contents, was hiding a lot of this complexity for us. So basically we replaced that, and we have to shoehorn these new asynchronous APIs into the LibreOffice view of the clipboard works. So we end up spinning the main loop during cut and paste until eventually the paste completes, and we have the full amount of data that we were requesting from the clipboard. Drag and drop is strongly related to cut and paste. So when it comes to management of the data that we get from drag and drop, or we reuse in drag and drop, we can effectively reuse the same code that we did for cut and paste. The GTK3 event-driven drag and drop has now been replaced by GTK4's controller-driven drag and drop. The changes to this versus the other controller conversion as shown in the event slide is much more extensive, but for the most part there are equivalent calls in the GTK4 than there was in GTK3. It's just a matter of puzzling out which one maps to which. What changes is in launching a drag and drop. The GTK drag begin now takes a GTK content provider argument, and that describes what data the drag and drop will provide, and then we'll write that data when requested. So to make all this work in LibreOffice, we have to implement our own GTK content provider, and that then translates the LibreOffice view the data to GTK's view. Drawing. The changes in drawing. The changes in drawing are the most extensive changes versus all the other ones. GTK3 was previously possible to connect to the draw signal in a custom GTK widget. You get back a Cairo context, and we just split our backing surface to that, and GTK will have clipped that destination surface to the areas that have been marked as invalid. When we know that part of our backing surface has changed, we are tracking the damaged area, and we just tell GTK3 with that GTK widget queue draw area what areas are now invalid. This is all changed in GTK4, but there still exists some routes to reuse our existing Cairo based drawing mechanisms to get something working straight away under GTK4 without having to investigate too deeply the new mechanisms of doing things. So to make all that work, I decided to use a GTK drawing area for our custom drawing instead. This is how it looks in GTK3. Just for reference, at the top you have your menu bar, which is a native GTK menu bar, and you can see in the GTK inspector window, which I've placed on top there, that you have a top level GTK window, and then you have a grid, and then that contains two members. The first member is that menu bar, and then we have the GTK event box, and that's the event box that we listen to for in GTK3 for all of our mouse events and other keyboards events, etc. Inside that then we have this custom widget, this 000 fixed widget. That's the widget that we draw to. We draw to that by listening to the draw signal in the previous slide. We can also host native elements like the sidebar widgets. We can host them directly in that fixed widget. In GTK4, as I said earlier, we have now changed to drawing to the GTK3 drawing area. GTK fix still remains, but now we've placed two of them inside an overlay. So what we have is a drawing area, GTK drawing area, that fills the entire window, and then we use the overlay to float that GTK fixed up on top of it, which means that we can still continue to put our sidebar widgets into the GTK fixed and have them up on top of the drawing area for positioning purposes. Side effects of the changes in GTK4 is that there is no longer the queue drawing area, only the ability to call the full GTK widget queue. So only that remains left to trigger the redraw, and on the redraw we're blitting our entire backing surface on every redraw, so on every cursor blink the whole thing is blitted again. This all works, and it feels fine in practice performance wise, but in the long run we may need a rethink on that one. The other part of the drawing changes, from our perspective, our drawing changes, is that GTK's foreign drawing API is removed, so there is no longer a simple route to render our VCL widgets to look like they are GTK widgets. Where we're using GTK widgets, this isn't an issue, but some of the remaining VCL user interface elements, like the application scroll bars in GTK4, revert back to their built-in original VCL look, which you may have seen in the demo earlier. User interface descriptions. In GTK4, the widget inheritance hierarchy has changed. So previously a GTK spin button inherited from GTK entry. So GTK entry properties could be used in GTK spin buttons as well. But now in 4 it inherits directly from GTK widget. Other changes are that the generic container API has been removed in favour of specific APIs for every container. So GTK box and GTK grid have their own APIs for adding and removing children, and the generic API GTK container add and remove doesn't exist in GTK4 anymore. So the user interface file format for GTK4 has correspondingly changed, and it's an error to load properties in GTK4 that were removed. And this can happen, as in the case of GTK spin button, where the property used to exist no longer exists. There's a whole set of other changes as well. Seeing as we're not planning to change over to solely GTK4, we need some sort of interim mechanism to continue to support both versions. So we manage this in two parts. First is basically after the part of the GTK3 migration guide, the preparation in GTK3 is to make the changes there that are recommended for GTK3 applications in advance of becoming GTK4 applications, and these are applied to the user interface files in Git, so these are statically done. So this script, the bin UI rules enforcer, it rewrites our user interface files to remove properties and elements that have been deprecated or contraindicated already in GTK3. For the most part, the properties appear to be accidental properties. Maybe somebody fat-fingered something or accidentally used the scroll wheel while hovering over the panel in Glade, so you get cases of where that double buffered property is set to something which is not something that we ever want to do. Or perhaps that a tracked visited links property has been toggled on in a GTK label, mostly meaningless accidental changes. That's the static part of things. Dynamically then, when we take these GTK3 UI files at runtime, we runtime convert them to the GTK4 equivalent properties and layout. This is conceptually similar to the GTK4 builder tool that comes with GTK4, except that the builder tool will only give you a kind of a template from which you have to make your final changes manually. The scope of possibilities of what you get in a generic UI file are too broad really to make a perfect conversion, but in our case we can take advantage of the fact that we have a uniform nature of our UIs, that they're all basically following the same pattern, and we can use the initial static script to find and identify and fix up any of the cases where there's some confusion as what the conversion should be like, and enforce certain rules there, so we continue to have a legal GTK3 version that we can convert automatically to create functional GTK4 UI versions at runtime. GTK image, GTK picture. In GTK3 you have a single class GTK image. In GTK4 this has been split effectively into two separate things. GTK image, which is a fixed ratio widget typically used for rendering icons, and then you have a GTK picture, which is less constrained. We have to basically decide at load time, at runtime, what type of destination GTK4 widget does the source GTK3 image have to be converted to. So if we can see that it's loading an icon, then it's a GTK image, which is the typical case. And then if we see that it's doing something different, such as the help about case, then we have to convert to GTK picture. So that adds a little bit of complexity to the conversion process. Other changes related to that is that you can't create either of them from a chiral surface anymore, but we continue in our GTK4 to keep our virtual devices to be backed by a chiral surface, and we often want to create an image from one of those. The argument they take now instead is a GTK paintable, so I've bridged that gap with a simple implementation of one of those GTK paintables called a surface paintable that then uses this GTK snapshot append chiral to append on the snapshot of a chiral surface to those widgets, so we can continue to use our virtual devices with the replacements in GTK4. So that covers all the things that work or can be made to work with a little bit more effort. There's a whole set of other things that I haven't really investigated closely yet. So for example, GTK has split top levels into standalone application windows and pop-up windows, and I've made no effort to do anything with pop-up windows yet. So where GTK itself manages them directly, such as in the menu bar or pop-up menus, then they work perfectly fine. But for something like the VCL toolbar that can have drop-downs, they don't work at all yet. Accessibility has also changed pretty radically in GTK4. I've made no effort to look into that deeply yet, so I just stripped it out of the .user interface files when they're dynamically converted from 3 to 4, and there's no code yet to bridge our existing accessibility implementation with the GTK4 one. GTK threads set local functions is also gone from GTK4, so Solar Mutex is no longer automatically acquired and released by GTK. I haven't really paid much attention to that yet. It doesn't make much of a difference when you're just using it directly as a user. Some of the other toolkits have a similar problem, so we can adapt the same solution used there for the GTK4 one if necessary. The other side of things then, GTK4 comes with built-in video support with GTK media file, which looks quite exciting, but nothing is making use of that yet. But it does look like it should be possible to replace our direct use of GStreamer with GTK media file instead, which would give us maybe more flexibility and hopefully a kind of a smoother, more integrated approach with the rest of the interface. So yeah, that's where we are. GTK4 port exists, and a lot of it works, a lot of it doesn't work, but it's clear for the most part what needs to be done to get those parts working. There are a few unknowns, but on the balance it looks very, very plausible that the GTK4 port will be successful. Thank you.